Hello, good afternoon, good evening. The time zone you are joining from. I'm going to present a still work in progress here that started in the academic context during my PhD within University of São Paulo and Sapienza University of Rome. And then we start collaborating with some industry partner here that was work with German company Generic. The title of the work is a decision support system towards a systemic perspective on technical debt management. And below is the name of all of my colleagues that are working together in this project. This is a very short presentation. Here is the table of contents. I will start with the main objective of this work is to develop a decision support system to assist decision makers when facing the challenge to decide on how to allocate resource among different maintenance activity types that usually have different objectives and sometimes even conflicting objectives. Specifically, we aim to support the evaluation of potential future scenarios by using simulations and help to evaluate potential scenarios that would be eventually economic or physically impossible to evaluate in empirical way. It also can serve as a communication tools to support to talk about technical debt's impact with different stakeholders, to communicate how intermediate causal and effect relationships of decisions taken now can unfold over the time with especially non-technical background stakeholders. So this is just a disclaimer. We are not aiming to develop a crystal ball. We are not trying to predict future scenario. We are trying to develop a tool that can uncover knowledge, that can bring common understanding of the context. So to make it less abstract, I just put in the beginning of the presentation the tool's main user interface. I'm not going to talk about it right now, just to don't create a big expectation on the interface, and so we can have a concrete we can refine what we are expecting with this tool. So the background, we took several of theoretical elements to develop this decision support tool or the simulation environment. We got inspired with the software evolutions law from Mary Lehman, especially in the last of his eight laws. He captured that the software evolution process is it's composed as a feedback system. So this is why we are talking about bringing a systemic perspective on technical debt management. We then need to set the boundaries of the scope of the model. So we took the definitions from Chopin and we took three different types of maintenance activities: the corrective, enhansive, and grumatives. One that deals with reliability violations, one that deals with functional requirements or business requirements, and then grummative that impacts directly in software maintainability. And directly related to the maintenance types, we also define a subset of quality characteristics that those maintenance types that represent a portfolio of projects or activities that we have to allocate different resources to deal with them. So we are talking about here in the model or decision support system, we are dealing with functional suitability, reliability, and maintainability. This is for dealing with technical aspects and for talking about economic aspect, because we are talking, we are evaluating the trade-off decisions of investments and technical characteristics. We brought here the technical debt metaphors and some of its components, and also some aspect of to estimate tangible assets And all of these elements we arrange in hierarchical evaluation structure. That is the goal question metric. The decision support system the simulation engine was developed by using the system dynamic approach. The system dynamic approach was created in the 6 by Jay Forrester to evaluate complex or dynamic complex contexts, and it consists of an iterative process, similar, for example, to what we see in the software development community. We can relate here problem articulation to requirements gathering, the dynamical hypothesis to the design, the formulation to the development, testing to build confidence in what we are developing, and the deployment as the policy formulation and evaluation. Just to go very quickly on how we get to the tool, this is, we started, for example, trying to investigate mainly the effect of technical debt on maintenance costs or investment here, depending on how we are approaching how we employ resources during maintenance or the software life cycle or runtime. So we took some primary and secondary data. We use here, we can call this as reference mode. We took a set of dynamic or patterns or how key variables unfolds over time, and then we built a dynamical hypothesis. We try to endogenous or a systemic perspective explain how different behaviors could emerge from interacting elements. Here's a notation commonly used in system dynamics and system thinking, a set of arrows and polarities. Some people call this as spaghetti diagram, but it shows here that how we capture several of the Leemann's law. Then we go to the models formulation that consists of derivative equations and computational numerical computation. And just here is an overview of the tool. We have the navigations, a set of KPIs and how they unfold over time. And then we have the levers and how to play with the model. And here is the navigation regarding each of the implementation. We can inspect during runtime how each of those variables unfolds over time. Each of these sections, we have the maintenance, grummative, perfective, goal evaluation, and we can play different scenarios. We start here, for example, we change a maintenance to a development of a new software, and we can in real time see how it changes the behavior over time. We change the allocation prioritization from enhansive to grummative activities focused on technical debt repayment. Then we can change the waterfall mode to an iterative, change the duration and the size of each batch size. We can use optimization to draw an allocation policy, and then inspect how it impacts each of different sectors. We can then refine different scenarios. Here, for example, we are taking the hiring delay and play and see how it changes. Big projects where mobilization and demobilization of human resources and see how we can work on this. My time is running out, sorry. And as future works, we are now.
Yeah, I think we'll stop there. There will be a discussion room where anyone who wants to hear more about your work can go there in just a few seconds. Thank you very much, Eduardo.
Okay, thank you. Bye-bye.